we can go ahead and go through. I think you made a lot of changes to Module Federation, the next plugin. A lot of simplification. So I'm gonna swap over to the screen share, and you can kind of walk us through what you were able to do.
Sure. All right. So I think the biggest change that's coming in. So I guess with version 7, what I started working on was dropping my whole promise new promise setup. So in version 6, and like the last few versions, I had released this beta for delegate modules, and that was mostly what I was focusing on, is pulling delegate modules in, making it kind of the default way that Federation works in Next. But from that, I ended up trying something new halfway through. I ended up trying something new like over the weekend, where I tried to see if I was able to drop the whole child compiler design. So the reason that we've had a child compiler is due to the incompatibilities of Next. The main one was sharing code. So if I mark a React or something as shared, even if I mark it as eager, Next will fail to run correctly. And there's another problem with eager sharing as well, is usually that also hoists the dependency into the remote entry. So in order to make Next sharing work, I'd have to eagerly share all of its internals, which means your remote entry would be like about 200 kilobytes to download. And Next still wouldn't work correctly. So what we've done is use a child compiler. So this is like the main Next plugin, and toward the bottom of it, I used to have this child compiler enabled. And when you go into the child compiler, it would do like quite a lot of stuff, but essentially I'd reconfigure like where the build output would go of the child compilation. I'd filter a bunch of plugins off of the build. I'd configure Module Federation, change the chunking format so they don't collide with the main build. Mess around with the sharing mechanism. So in the host build, I would share React under a different name, and I could kind of shim it into the child compiler. And then I pretty much just manually implement most of what is needed for like a Federation build to work. But overall, it was quite complicated to have to go and try and implement this whole setup. As you can see, like the plugin is quite long, and the logic around it to like fire off, watch mode or rebuild in development mode was quite flaky. Like all of this logic here is just building it and running the child compiler. Not actually the child compiler doing anything, but starting it in the right mode and running it at the right time. So in version 7, what I've thought about was, would it be possible to just drop the child compiler completely and try to run it off the main build? And I've had some success in the past with it, but ultimately it's never actually worked out. So this time around, I decided to just give it another go, and it actually ends up mostly working now. So the idea behind this new design is, let's see if I go up into the top here. The idea behind it is I've got my usual setup that I've got, check if there's certain things there, apply it to the right build, and then if I've got my shared modules, I've added some warnings just so that users don't reshare things that I'm already sharing internally, because I do it still in a specific way. And then I kind of get down into configuring the plugin. Put the node plugin in there, make sure certain things are always internalized in the build. And then I kind of go down here and, I have my usual loaders, and so on. But what's been the key to make this actually work is this plugin here that I've created, this add module plugin. So what add module lets me do is move the dependencies around in the Webpack graph, move them into the right location. So usually, if I were to share something or whatever, it gets moved somewhere else in the graph. And Oh, sorry. And wherever it gets moved, that usually isn't the right location for it. Next doesn't start right, or it goes into the wrong container, or something like that always happens. So um, what add modules lets me do is just go through the graph and move certain dependencies into the chunk that I want them to be in. So the biggest thing that add modules is really doing is it's hoisting the code for the remote entry back into the host's Webpack runtime. So now if I need something like React or or anything else, what ends up happening is inside the Webpack runtime, I've got a reference point to React that'll exist when I execute that specific module. So I won't get the usual eager sharing failure. How I'm actually doing that is if I click into this plugin, it's pretty simple, but first what I do is I find all the delegate modules and I hoist them into the runtime to make sure that they're always in the Webpack runtimes. And then what I do is I go through and I add a couple other things. So the big one here is this internal hoist mechanism. So if I see that, I move the module and pretty much I move it into whatever the current runtime is that I've got set in the options here. So why this is super helpful is, one, all of my remote entry code that I need to start the application is actually in the runtime that it's supposed to be in from the get-go. The second big one is this hoisting mechanism that I've got here for moving modules up the tree. So what I do with this is I do have an empty file. Yeah, internal, I have the container hoist, and then I've got a delegate hoist. But this is pretty much the only thing that I have sitting inside of it. So it's quite empty. And then I've developed out a few new loaders here. So I have my normal delegate loader, which still does what it's supposed to do. And then I've developed out a hoist injector. So this is quite simple. It just requires that empty hoist file somewhere inside of the host application. And then I get to the share scope hoisting, and this is kind of what tied it all together, is I go through here, I look in your shared options of Module Federation, and I loop over all the share keys that you've got. So anything that's set to eager where import is set to false, I loop over those. I think if it's just set to eager, yeah. If it's just set to eager, I loop over those. And what I'll do is create the share scope object for it. So in this case, I've got, say, React, and I just set it to 0 version because the version doesn't really matter. And I mark it as loaded and eager, and then it's get call. Usually this would be like a dynamic import. So when you can start an application asynchronously, Webpack's going to load all the share scopes in, see which one has the best version, and then call the get method and await it to respond with the module factory that's got the dependency at once. Since Next can't start asynchronously, I need to be able to do this synchronously. So there is one kind of trick to it. So since I don't want to actually move React around in the graph, I don't want any of the remotes to attempt to negotiate a different version of React or something like that. So what I'm doing is inside of the internal file here, I think this is it. Yeah. So inside of here, this is the default share scope. So you can see that I have React as a singleton, but I have it marked as import false, and it's as eager true. So when I mark it as import false, what it'll end up doing, if we go and look in one of the Webpack runtime outputs, what it ends up giving me is a server, and here we go. So now if I go and search for React inside of here, I should end up getting, let's see, just jump past all of this. Yeah, so I get to the init external section, and then I've got these two initializers on here. But those are just my remotes. React itself isn't actually shared from the host. It doesn't register that it's got a copy of React or anything. And because I've set it to false, it's going to expect React to exist somewhere in the upper scope. So somebody else is going to give it React. Even when it's the host, it's treating it the same way. So it expects React to already be provided through some share scope mechanism. It's not going to do anything or register anything for me on its own. So this makes all the remote entries not attempt to load React or double load React or anything like that. So it solves one of the issues that I've had with initializing these applications. But the side effect of doing this is it also makes the host not load React either. So now React just doesn't exist at all. It's treated as external, and it expects ShareScope to provide it. So with runtime hoisting and my share hoisting, what I'm doing is I move React, or the kind of wrapper code around what React is going to do. I get that moved up so that when I'm booting up the Webpack runtime here, it's going to go over these startup modules because these are all in the graph already. So these are the two remotes that I use. These are each delegate module. And then I go down to this hoisted one where I've got my internal module hoist system. And now in here, I've got, a key with React and whatever else. And then this require call, since React would be external, if I just left this as require React, I'm going to be stuck in the same problem. It's going to go back to Federation, and the host is going to believe that it doesn't have React because somebody else is supposed to supply it. So what I do over here is I don't actually call it React, but instead I call it React Pop. And I put this in front, which disables any loaders from passing over it. So now when I do that, Webpack sees this as something different to require React. So this is not equal to that. So now what ends up happening is I can essentially double bundle React. So the first React is externalized, so it never actually ends up in the graph. But this pop React gets pushed into the module graph under a different name. So nobody's going to look to require it. So what I end up doing is I assign the other location where it is. I put this into the share scope here. And then at the bottom of the graph, so once I set up share scope for the remotes, at the bottom of the graph, I set this up for the host where I sideload it. So now I take the original React request, which is going to point to ask Federation for React, and I reassign it to the actual reference, this React pop that exists. So now when Webpack boots up and it tries to go and get 6689, it's actually going to get 733. So now everything is synchronously there, but I haven't had to mess with the mechanisms of how Federation works too much. According to Webpack, it seems to all function. It's going to look in the module graph, it's going to find this, and it's going to exist. So it will, it won't see anything's wrong. It thinks it's already there, and I've injected it just in time from a different location. So if we go back to my loader, it's a little easier to look at it in this hoist loader. So this is essentially what I do. I make the require call with React and pop, and I loop over this and I apply this to everything that I'm doing. And then below there, I implement the side loading logic. So this is where I side load whatever the current dependency is. So I go into Webpack modules and I call require resolve weak, which is going to pretty much return the module ID of the dependency. So now I'm getting React, and that's going to be, 6687 or whatever. And I'm finding that inside the Webpack module graph. And then what I'll do is I go, okay, well, now that actually equals, and I require resolve weak, and I get the reference that I've loaded in up here. And then I find this in the graph in another place. So now the only place that actually uses React pop is this file. So that means the rest of my dependencies still use React, which is supposed to be external, so they won't actually see that React pop and React are the same thing. So that's what I'm doing down here, is I reassign the modules so everybody who's looking for React actually gets the graph reference to React pop, which is synchronously available. So now Webpack starts up just fine. And then at the bottom, all I do is I go and I set my share scope default, and I assign whatever exists there with my eager object that I've just generated above over here. And then, I pretty much inline all of that and load it into my hoist system along with whatever else is below it. And once that's done, it essentially lets me start the application up in a synchronous manner with the dependencies that I want already available. And I don't get any initialization issues, and everything pretty much works the way you would expect it. So that solves the main problem of I can't share anything and use Federation with Next on the single build instance. So with the module hoisting out the way, that's most of the problem solved. But there's still a couple other interesting scenarios that had to be dealt with. One of them is I need to actually get the hoist code into my code base to begin with. So when I do internal delegate hoist, I have two places that I do it on. So the first one is I have a little loader here. And so this loader is a preloader, and it only looks for the document file in Next, which is like the first file that Next requires. And inside of there, I inject the hoisting code. So now it requires this internal delegate hoist file. Right after that, I have a loader that processes that hoist file, and that's going through that whole share scope loader that I just showed you. And then I just pass in the federation options here. So this works for the server, but in the browser, I have a bit of a different strategy to take. In the browser, we have the main chunk. So that's anything common, anything that's shared usually ends up in the main chunk. All the pages depend on the main chunk. So in order for the application to start, the main chunk has to have been parsed and loaded, and then the page chunks will start being parsed and loaded. So the nice thing is this gives us an opportunity to inject modules somewhere into the graph that will exist before the application is fully initialized. So server side doesn't have the concept of a main chunk, which is why I have to put it into document, kind of sideload things in there. Client side we do. So a nice trick with Webpack is if you create another entry point with the same name as a different entry point, Webpack will merge the two modules together in the order that they were created. So now I have internal delegate hoist, and now that's ending up inside the main chunk. So by loading the main chunk, I've got my hoisting mechanism already activated. And then I can go and utilize it however I want in a synchronous manner. So that's kind of like what I'm doing for the browser side. So the other really interesting trick here is I've done this in the past, but I didn't need to do it for this scenario, I believe. But I've also done things like that, where I'll add runtime code to the remote entry itself, because the remote entry is just a name. So whatever the name is you give it here, that's kind of the chunk name that comes out underneath. So if I add another entry point with the same name as a different one, they merge together into one entry point. And so I'm using that concept here, but on the main entry. So that takes care of like starting the application in host mode mostly. All the modules are in place, and now my synchronous initialization will work. Then I actually get to configuring federation. So first, I set it to runtime false, which means create a new separate remote entry that's fully fledged with the whole Webpack runtime in it. Then inside of here, I still want my remote entry to have the hoisting code for delegates. So what I end up doing is I actually have it expose the delegate hoist as well. So now Webpack sees that this is used somewhere within that entry point, and I can now find chunks that are dependent from the entry point down and again, hoist them back into the actual runtime itself. So this just makes sure that it's tracked in there. And if it's tracked in there, I can find it and I can move everything around in the graph on either runtime. So the host runtime behaves differently to the remote entry that it generates. And usually Federation does not allow that. When you configure this, it configures how the host is going to treat dependencies the same way that the remote is going to treat those dependencies. What I wanted was a way to say that the host treats the dependencies slightly different than the remote does, but only the remote treats them in a different manner. So this tactic allows me to make them operate similar to what I was doing in the child compiler, where I was saying, mint a new graph for this entry point and effectively handle the dependencies separately from how the parent is handling it. But now I don't need to use a whole child compiler. So some perks there are much faster builds because I'm not essentially building the app again. And the caching is a lot better because the chunk names are the same as the chunk names the host uses. So if the host needs React or something else, I'm not technically double loading it depending on the combination of how I run it, because they're actually sharing the same chunk graph end to end. So bringing this in here pretty much got everything to work the way that I wanted it to. And then there was still one other area that I had to go in and do. So this is just for, my delegate module loading and stuff like that. I also do it at the preload stage. So this is before loaders start running. This ensures that everything's put in place before any additional processing gets done. The other thing that I had to do was I had problems with the automatic async boundary. So that worked before in Next.js and child compilers. But this gets tricky when I have to apply the boundary loader to one file. Because what boundary loader does is it looks at your page import and it moves it into a dynamic import. So if we go and look at boundary loader, what it does is, it kind of just does this. So your page actually ends up being this. And then this is importing the original page underneath. And I do it with another import like has boundary, which means that it's a different file. So now Webpack will treat it as a new module and re-require it without boundary loader. So my page is just a dynamic import to the real page. And that works quite well. But there's a problem with Next, which is when I go and expose these pages, it's going to run through boundary loader as well. So this creates a bit of a problem because now I have a dynamic import for Next Dynamic to dynamically import whatever I'm doing. And if I'm dynamically importing a federated page, the page I'm exposing to the end user is also going to be this same piece of code on their end. So now I have a Next Dynamic going into a Next Dynamic. So I double dynamic import the page, and that causes some issues with Next because Dynamic doesn't really know how to wait for like suspended modules. It runs, it expects them to already be there, and then it triggers a kind of set state. And if the module isn't already resolved, it'll be null, and then it'll set state when the promise eventually does resolve. So double loading them is a bit of a problem because Next doesn't know to wait for another dynamic import that just came into it inside of another Next Dynamic that isn't ready. So double loading the modules was quite tricky. And this one I probably spent like a day trying to figure out how to make async boundaries still work, but not cause a hydration error on the front end when one of the federated modules that I'm loading is the async boundary page that is usually destined for the host to actually use to, be able to load shared modules or whatever else in an async manner. So what I ended up coming up with here to try and solve this was I make all of my pages actually just attach another key onto the kind of function object, which is called underlying. So now what I can end up getting is I can either get async boundary, which is the default export, and that's wrapped in Next Dynamic. Or I can go get the async boundary dot underlying, which is just the dynamic import. So I can skip going through another Next Dynamic, which is going to want to track that the promise is already resolved and then set state. So even though everything is there, when it renders it through two Next Dynamic back-to-back imports, it will show up as pending and it will fail to hydrate. Even though its server renders correctly and technically everything's there, it's just because there's another promise in it that has to immediately resolve that is kind of the issue. So how I worked around that was with this kind of underlying thing that I add on to it. So now what happens is hosts and remotes either expose or just consume their own pages using this kind of thing. So I go into Next Dynamic, I have my dynamic import where I go and get whatever I'm trying to get. And then I'll check if it's got a underlying inner module attached to it. The only ones that'll actually have an inner module attached to it are ones that come over Federation, because Next is going to go and Babel this import and churn it into a different object. And the object that it's going to give me is not going to have the underlying part. It's going to have already resolved one layer into it and give me the default export that's inside of the dynamic import. So only when I'm pulling federated pages across does this underlying primitive actually exist on the module that I get back from the promise. So now what I can do is I go, okay, well, if it's there, then I know that this is now a federated page that I'm pulling in, and I can await underlying, which would already exist because this is, this import is the same as that import. So all I'm doing is saying ensure that the promise is still resolved, and then if an inner module exists, then use the default export of that. Otherwise, use the next dynamic one itself. Like, use the default one. So then this would have next dynamic wrapped around it. This one would not have next dynamic wrapped around it. But since I'm in next dynamic right here, I don't want next dynamic wrapped around what I'm about to return to next dynamic. So this is a way for me to switch between them depending on how it's being consumed and not introduce nested lazy calls. So with this in place, this solved the other issue of allowing sharing to still work and still keeping my async boundaries. So that kind of solved the other big problem where I had to split the builds and treat them all differently. And then I believe the last piece that was important to tie together was, was this down here. So I configure Module Federation plugin and off it goes. And then I go, if it's not the server and I'm exposing stuff, I actually add another Module Federation plugin back onto the build. So now I've configured Federation twice for the browser, but this time the name is called single. So the idea here is when I say that it's runtime false, it's going to create a whole new Webpack runtime top to bottom. This works fine when you're importing remotes from, other builds. But in the case of, let's say I'm on the home application and I import checkout, and checkout imports title from home, checkout's going to want to use the host's own remote or load the home remote again and try to load its exposed module through it. But doing that overwrites the chunk loading globals inside of the browser for that remote entry. So now any new chunks coming in are pushed into the wrong Webpack runtime because there's two competing runtimes on the page and they're not sharing a graph. So what I have to do is I have to make sure that if a remote's requesting the current host's own exposed modules, I want to still use the main runtime chunk that the host has so that I'm not having to load another copy of the host's runtime fully fledged on the page. So runtime chunk single will create a partial Webpack runtime. So it's not the whole thing, it's not the whole module graph, it's just like 3 or 4 functions. And that won't work independently. But if I'm on the page that's already the host, then it would work. So I needed a way to be able to actually figure out, am I already in the right host? And if so, I want to load the light version of that remote, but I don't want that logic to have to be put on the consumers and all of that to try and figure out, because it becomes complicated to try and understand when something should be used and under what scenarios. So what I ended up doing was creating this little single one where I say runtime is undefined, so now it's going to just slice a piece off the main Webpack runtime. And then what I do is somewhere in here, I've got it hard-coded right now, and I need to fix that. Yes. So inside of here, what I'm doing is I say that inside the delegate module, since the delegate modules are the thing that start at the very beginning of the application, as Webpack initializes everything, I can go in here and I can just set something on the window called like home app, and then I'm just using the Webpack chunk loader, which is the low-level way to tell Webpack to load a chunk that it knows the name of. And I'm telling it load the single runtime chunk. So just add the other little snippet of the host's remote entry, add that to its startup. Now, since window home app exists, when any remotes are looking for, when any like sub remotes have an import to the home app, they're going to search and see, is it already initialized? Is it already on the window? If it's on the window, then I'm not going to inject a script because I've already got it. Somebody already did it. So I'm telling the host to put window home app there. And then once this Webpack chunk load fires off, the code inside of it will replace window home app with the actual get and init interface. So it starts out as a promise, and then once it resolves, it's now the get and init container. So all of my downstream applications that might need to consume something from the host, they're actually going to get the host's own remote, and the host is the one saying that it's provided. So they all just get it automatically. Nobody actually tries to inject it if their host is the application of the remote that they're currently trying to inject. So tying all that together gets me around chunk loading issues. It allows me to work with the single graph of Next.js. And it still allows me to create a independent remote entry that I can use when there's no parent application around that has the other half of the module graph in it. So it's kind of three main pieces that get tied together here. It's module hoisting, slicing the runtime correctly for the consumer, and then processing how dependencies and how pages are loaded depending on how it ends up getting consumed, so that I'm supporting several different conditions. For the async boundary loader, I think the interesting thing there is I'll probably use a very similar strategy for supporting React server components, where I need two files to behave as one, I need two different files to behave as one file depending on how it's consumed. I've now got a pattern for being able to determine a different strategy for consumption depending on what application it is. So with that, I should be, maybe with that and a bit of delegate module work, I should be able to support server components where the server component is actually one of two things, and it depends on how the host or how the consuming application wants that component to be. If it's a server component, it'll return like the proxy wrapping function. And if it's a standard like use client or just a standard SSR component, it would just return itself the normal way. But now I've got several conventions for actually detecting what the scenarios are and how to treat a module as something else, in a kind of scalable manner.
That's pretty sick. So you mentioned a couple times that it's more performant. Do you have any ideas roughly the difference in bundle size and roughly the difference in build size or build time?
So the build size should be about half the footprint of whatever you were putting out before. Since I was essentially just running Webpack 2 more times, we were creating 4 builds. I just stuck them in the same folder as the other builds, so you didn't really notice. But when you upload that to a Lambda, you're essentially, doubling the payload size. Whenever you would pull down chunks from the application, you would be pulling down, you should see all of my federated modules, they usually end in -fed, -fed. So that kind of made sure that they don't collide with the host's modules. But that means that, if I start out in checkout and I load the component library, I'm going to load like component library fed. But then if I go to a different application and I load it again, component library could come through as not component library fed over there. So technically you would have the opportunity of downloading these things twice depending on how you entered the application. So with that gone, now it's as efficient as the Next build, and I'm recycling the chunks that Next itself uses as a host. So payload size is a lot smaller, download size is a lot smaller. Then on the build timing size, it's again way less because I don't have to essentially rebundle an entry point with another copy of Webpack and make unique chunks and reparse the whole thing manually. So on the memory footprint size, I'm not sure on how much memory it saves, but I believe it should be about 3 times less memory roughly. And then on build speed, it should be twice as fast since there's half the number of Webpack builds being handled. And because they're not handled in parallel like before, that's less stress on the threads. So I'm able to actually process the single build quicker because the machine isn't spreading its resources so thin. So overall, I'm seeing, roughly 3 times better memory use and twice faster build times, as well as twice improved, runtime performance.
That's pretty awesome. So when do you think this is going to go live in a place where people can consume it?
So right now I'm busy testing some final things. So I think the new hoisting system was basically done. The only thing I need to do is I need to create a loader out of this. So instead of me just writing window home app, it needs to be templated. Window, name of current host's remote, and go find the chunk ID, and a couple small details like that still need to be polished up. The biggest thing that I'm trying to get running now is when I use the default delegate. So I merged this code into this branch the other day. Because originally that was what I was going to make V7, is just allow delegate modules to be the default. And then I got rid of the child compiler, so I went back and got all my default delegate stuff that was intended for V7, and I'm starting to reconcile the two halves. So bringing that in has posed a few new challenges that I'm running into that I need to go and figure out. Okay, and now we're just timing out. Well, that's a different error than before. But yeah, so I think overall, we are quite close to being able to cut a new release. There's a few last things I need to patch up on, like using delegates as the default. Most of it's related to the new work that I've done, where Webpack parses this a little differently when it's a NPM package versus when it comes from userland as the delegate module. So I need to make some adjustments to kind of support this variance. But once that's done, I think a lot of things that are left is just deleting code. So the whole child federation plugin, this whole thing will be deleted. So this huge plugin, and most of the things that it imports is no longer required. So I need to still comb over the code base and delete a lot of stuff, because the footprint of code required has shrunk quite a drastic amount. But we are toward the end of getting ready for release. I'd hope maybe in the next week or two, we would drop version 7. And then that would most likely, assuming we don't have any bugs or anything, that would probably put to bed the major engineering efforts that have gone into supporting Next.js, because this is quite a stable mechanism now. There's just not that much. It's not that different from supporting Federation on any other stack. There's a couple loaders and module hoisting and things like that, but a lot of that is to do with delegate modules and not entirely related to Next. So we could see all my delegate work getting pulled out into its own package or its own set of utilities. And then what's left inside of Next as a core plugin is really just going to be module hoisting, which isn't very big. So with all of that done, it means that any progressions that I make on Federation elsewhere are quite easy to apply back to Next.js. So then I could look at things like React server components and supporting that in a simpler application. Once it works there, I can backport it into Next quite easily, because there's no longer a real mechanical difference between Module Federation on Next.js and Module Federation on a standard vanilla Webpack styled application.
Awesome. Sweet. So I'm going to get this all cropped up and get this shared out, because I think this is going to get a lot of people excited about what's coming with Module Federation. And then we'll make sure that we keep everyone posted on what's going on.
Awesome. Yeah. This is definitely going to be a nice release to get out there. It's been a lot of work to kind of fine tune it down, but I do believe we're kind of at the stage where, we've wrangled Next into behaving like a normal application. So despite that they don't support it well, we've turned it into doing things with the Module Federation plugin. Now that these other plugins are there, is kind of standard. So I'm quite happy to reach this point, and I do think it's a good place to leave the project as I start to look at stuff like modern JS or other frameworks that are geared better for distributed systems or like larger scale. So, I'm quite happy to leave it there. Still maintain it, of course. It'll still go along with progression of my ecosystem, but it's not like the main thing that is the most complicated to work on. It should just be able to inherit improvements that we make elsewhere.
Nice. Well, cool beans. I think we'll call it a day, and then we'll see as soon as this gets released. Cheers. Thank you. Talk to you later.